Yes, welcome to our webinar, Smart Cameras versus PC vision system. Which is right for your application? What was the intention of this? Of course, we get always a lot of people who ask us, what is the right hardware? And why should I use a smart camera? Is there any reason to use a smart camera? And in which case is the smart camera maybe the better solution than the PC or the embedded system? I think maybe PC doesn't fit to the general meaning. I think in most cases we discuss about embedded systems, PCs, and let's say smart cameras. As you can see, of course, the view is always based on from a software side on one point. So you can see here we have a lot of different smart cameras implemented, much more than you can see it here. Anyway, PC or embedded systems are generally working, so there is no reason not to use PC or an embedded system. The question is there only what operating system fits best for my needs. On PC systems, of course, you have the choice between right now Windows and Linux. Windows on x86 systems, you have the choice between Windows and Linux, and on PCs with ARM platform, you have the choice between Linux and Linux, as you have the choice between Linux and Linux if you use a smart camera. But at the end, finally, if you have a application which runs on both systems, you are free to select which fits best to your needs and not which operating system fits best. Of course, in some cases, Linux is maybe the better choice, especially if it's built in the machine. You are not depending on the update cycle of Microsoft, and you're also not depending on the errors which Microsoft built in the different operating systems. Of course, Linux has also some errors. That's not the question. So let's have first a look to the different options. Of course, every project starts how do I deploy it, and how is the processing which I need for the part, and is it necessary to scale it? Normally, in most cases, you know exactly the task which have to be solved, and therefore, if the CPU performance of a smart camera is enough, then why looking for a more performance system which you have some additional computational power if you don't need it? So this is a question which immediately have to be solved by the one who makes the solution, and he has to think about what do I need. Therefore, a short overview, not a complete overview about the performance and the architecture a little bit. Of course, one moment. Nice. Of course, this is only a short overview because to do it in detail, one have to look also in detail to the hardware which is selected for this system, for this application, for the solution. And well, for high performance systems, maybe the x86 based systems maybe are the better solution, of course, because the CPUs are and the infrastructure are mostly better than the embedded ultra compact ARM-based systems. Why? Simply because the PC manufacturers deliver not only a CPU, they also deliver the chipset around the CPU, which is really important for the total system performance, especially if we make machine vision solutions. For machine vision solutions, as we know, we have some large data chunks like images, which have to be transferred to the main image and operated on the main image. And maybe we have to also to make a copy for some reasons. And then this infrastructure with the x86 systems, it's much better than the infrastructure of an ARM system, especially if we look to smart cameras. Of course, that's not true for all ARM systems. Right now we know a lot of ARM systems which are used in server platforms where the ARM infrastructure is also very powerful. I would only remember the latest ARM platform which is used by NVIDIA. So these systems are at least, or let's say, they are more powerful than the x86 platform. So you cannot generally say the basic platform, the ARM platform is always not so powerful than the x86 based platform. At the end, the application defines what is the right hardware. Can I use a smart camera with an x86 or with an ARM CPU, or do I have to use a PC with an x86 or, of course, with an ARM platform? Unfortunately, the ARM platforms are mostly more expensive than if they are performant than the x86 platforms, but they are really good. So to say it simple. Let's have a look to some of the x86 based platforms which we have implemented over the years. And of course, if we look to these x86 platforms, finally, they were never a real big success. In most cases, why? Because they are too expensive, finally. Of course, we talk always about performance, but in most cases, we talk also about price, and price is finally at the application really important. And of course, the x86 platforms are related to a normal PC much more expensive than if you buy a normal PC and you use this for your solution finally. And therefore, the smart cameras are today mostly used in very, let's say, simple application where the additional price is not fitting to the task which have to be solved. Especially we see these small ARM platforms here with smaller ARM CPUs. And of course, they can be used for a lot of application, even from the speed position. Let's say the average machine vision application runs with 5 images per second, 5 parts per second. So for this speed, the hardware performance is never a real question to not use a smart camera. Of course, if you have some specialized application like AI, then maybe not all smart cameras fit to the needs you have for the speed requirements. But in this case also, right now there are upcoming smart cameras like the center one from Baumer, which have an NVIDIA CPU inside with GPU, which allows us to run our standard AI framework. So not the reduced framework, which is for the edge devices. So if we look to the eye check systems, this system has an edge processor inside and can also run somewhat fast AI, but specialized networks which are fit to these AI processors. So that means even if you use AI, it's not there's no real reason not to use a smart camera. The question is at the end, does the price fit? And finally, also in this case, the NVIDIA-based cameras are mostly, in my opinion, really expensive, which means most people don't use it. That's, that's not only my opinion, that we can see it, how well these cameras are sold to the customers. Of course, it's mostly much cheaper to buy an NVIDIA embedded board with the same CPU and GPU inside, which at the end, even if you buy a camera and connect this to the ARM platform, it's much cheaper if you use for maybe a small cabinet, which costs you less than 100 euros, and you have the same speed like this. Related to, let's say, this Baumer camera, or if we shift to the next one, to this ALECS camera, which price-wise is in the 3,500 to 5,000 euro, like the Baumer camera by heart. And inside is anyway the Jetson Orin hardware. So if you compare price-wise the Jetson Orin platform and any of the ALECS cameras or Basler cameras, and you use the Jetson board, then you will realize, okay, maybe you can get it for 1,000 euros a platform with the same platform related to the 5,000 euros or plus minus, which this embedded platform charges. Finally, the nice thing is, of course, you don't need housing, you don't need a cabinet, because you have M12 connectors at these cameras, and you simply can put it directly in the production field. But at the end, one have to think, fits this to the needs I have? From the processing speed, of course, even for a lot of AI application, the Jetson Orin, but also the standard ARM CPUs, which we see here, are fast enough for standard applications like measurement, OCR, and other code reading applications. So then finally, the question is, what is the difference? And I simply answered it a little bit in the last few minutes. What is the answer between this smart camera platform versus the industrial PC or the embedded platform? If you have any industrial PC, it might be in 19 Zoll rack mount system, or this small PC embedded platforms, or maybe a total small, in this case, Jetson, but also Raspberry Pi or Android or whatever ARM system. The CPU speed is mostly not the problem. Of course, if you have the PC platform here, you can use any GPU to improve the AI speed with this 19 Zoll systems, so that you can run even complex AI. So right now, I look to the real CPU or GPU algorithms which needs speed. If you don't have these needs, then you could use these smaller systems with an edge CPU inside, like the TPU from Google, the Coral, or the Halo from Halo Systems, and some the NGX CPUs and NGX CPUs from the CPU manufacturer, which is, for example, in this small camera inside. So if you have this specialized networks for AI, then you are free to select also one of these other devices. There you don't need the real GPU device. If you want to use any general network, of course, it's much easier because one don't have to adapt the networks to the needs of the hardware. So in that case, maybe the ALECS from Allied is good, or the Bauma camera. Both have an NVIDIA platform inside, which allows us to run the software completely without any adaptation. So this is the simple answer for that. So maybe a short overview between the smart cameras. Of course, we saw mostly now smart cameras with an area scan CPU inside, area scan sensor inside. So not most, all of them have an area sensor inside. That means they are main, or you can use it for any application where you use an area scan camera, a normal matrix sensor. And so you get these smart cameras, of course, with gray and color area scans. And I have as an example here this smaller one, but all the others which you saw before have exactly the same areas, not exactly the same, with different resolutions, of course. And because most of them have, as you can see here, has a C-mount lens on in the front, you can simply select the right lens to adapt it to the right field of view. Finally, the question is, if you use a smart camera and you have to adapt the lens, it's a question, does it fit to the needs which I have? But of course, there are also a few 3D triangulation line sensors like this one here, which has also an ARM CPU inside and runs and can do 3D directly inside of this smart camera. As you can see here, as any other triangulation camera, you have here a laser line, and you have here the sensor, like triangulation systems work. Then you have, of course, the area scans, and this one is also a special smart camera. At the end, what is a smart camera here? It's a smart camera because everything is built in. You have here a light scan camera, a light. So as for this camera, you see here you see the light, the lens. Here you see the light, the lens, and here you have a line scan camera and the light. And this is a ready-made system. It should be, or at the end, it's a smart camera. Eye sorter is a smart camera if we want to look to this. And of course, it has also the typical smart camera preconditions like M12 connectors, so that you can use them directly at the production belt without an additional cabinet. Of course, if you integrate everything in the housing, you have to make some small constraints about the speed. Even the NVIDIA platform ARM systems are not endless fast related to x86, or of course, if you use the high-end ARM systems, they cannot follow up these high-end systems. But the idea is, I think at the end, or the real choice is to reduce the need for an additional cabinet. Simply have one component which you simply attach to your production line or inspection area and connect it with an M12 connector for power and I/O, and then you have the inspection system. As I started with these CPUs inside, of course, there is no problem to solve applications with 5 parts per second. And if you look to many machines, because of course I know many people discuss about the speed and how fast it is and so on, but the machines are finally not so fast. If you have the average production line, it runs with 5 parts per second. If it's 10 parts per second, it's fast. 15, it's really fast. And there are very little high-speed applications like stamping machine or bottle filling systems, which run maybe with 30 and 40 parts per second or cans per second or whatever. So let's say the majority of all applications and also the tasks which have to be solved is anywhere in the 10 parts per second. And of course, then the question is, you can use these smart cameras. You don't need a cabinet and you simply make the solution. If you need more sensors, like one sensor, of course, each of these cameras and also the other ones, which I showed before, have one sensor. If you need more than one sensor, of course, then a PC or embedded system is better because it has the option to connect multiple cameras to this system. Beside the connection of multiple cameras with multiple images, gray, color, 3D, thermal, hyperspectral, then the question is, the answer is very simple. A PC-based version is, of course, the better solution for this application, finally. So, of course, if you make the choice to select this big PCs, because maybe you have an AI application which needs, of course, one of these big GPUs, then you need this bigger 19 sol system where you can simply plug in the card and run it. So for all the other smaller, maybe you have the option to add an edge device, and then you can run the edge device, run on the edge device the AI, like the Coral chip, the TPM. So it's not always necessary to have a GPU from NVIDIA. There are some other very good AI performance systems from also AMD, but some other manufacturers like the TPMs from Google or Halo, which allows you to add these small boards onto to the small embedded system like this one here. Of course, the scalability of the PC-based solution or embedded-based solution is one of the major advantages. First of all, you have multiple options for cameras. Maybe one camera is not enough for you, so you need more. Then it's not a question. Then you need multiple connections, like in this embedded system you see here. If you use GigE cameras, for example, you have multiple GigE ports with maybe also PoE, so that you simply can use any camera from a manufacturer and simply connect it and build up your system. And finally, if you do the math at the end, if you use a PC system and you need more than one camera and compare it with two smart cameras, finally, even price-wise, the PC is the cheaper solution, also the embedded system. Not only with the x86, also you can use an NVIDIA Jetson board with 2 GigE interfaces or a Raspberry Pi, for example, many other ARM systems, which multiple USB 3 or GigE interfaces to make these complex setups for the solution. At the end, what brings you the best and solution for your application? Maybe an embedded controller connected to some cameras. There are a lot of these are only some examples of the cameras. Right now we support more than roughly 100 camera manufacturers with their native drivers, and also of course with EyeVision and GineCam support. So you have a wide range of choice. If you use a smart camera, of course you have to use the camera which is built in, which you buy for that solution. Depending on what you want to do, you need sometimes these, let's say, also kind of smart camera. The question is right now, what is a smart camera and when is a smart camera a smart camera? So at the end, the application which you want to solve and the speed of the machine describes what fits best for the solution. Finally, we can always help to select the right solution because, of course, our main idea is we have a software which supports, as you can see here, all kind of smart cameras from, let's say, all current manufacturers which we know from Europe and also from outside of Europe, to say this a little bit. And of course, we run the software either in these smart cameras or we run it on any PC with an ARM CPU or with an Intel CPU inside, with Linux and Windows, so that you can use the right solution for application. Maybe you have a 2D area code reader and you need additionally a 3D image. Then, of course, the PC solution is always or the embedded discrete solution is the better one because you can connect the two cameras or the three cameras. Of course, you can connect also a 2D area camera with a triangulation camera, with a thermal camera. In all of these cases, the PC, let's name it PC, in which version ever is the better solution because you simply can connect the right camera for your need. If you know exactly, okay, I only need this color image from whatever it is, and I have to inspect the colors. Of course, the smart camera might be the right solution. Then maybe it's only the question, does the price fit? So this is something which everybody have to solve by himself, especially if you use an embedded system, you need mostly a cabinet. And if you calculate the embedded system with the cabinet and with the external camera, maybe the smart camera is a cheaper solution. But this is a simple calculation. The speed shouldn't be, in most cases, the real reason to do the selection between the smart camera and the PC. And because in earlier years, of course, the connection to the machine was mostly not done with bus systems. At that time, you did the connection with I/Os, real digital I/O systems. Then, of course, the smart camera had mostly. It changed also I/O lines, which they still have, and of course, many standard cameras do have also some I/O lines. But nowadays, most people use one of the bus systems. Maybe it's Profinet, OPC UA, Modbus, Ethernet IP. In this case, of course, you need simply an additional Ethernet port to do this communication to the machine. And also, the smart camera can do this. Smart cameras have these PLC I/O lines, but all of them have at least one Ethernet port, which can be used for the programming, but also for the communication to the machine. So there is also no real reason not to use a smart camera, especially you don't need the Ethernet interface for the image transfer. And if you have a PC-based system, mostly you use the Ethernet interface if you have one there to connect the camera to the PC, and or you use one of the USB connectors to connect it to the PC. What I, of course, didn't mention until now, which we should round it up a little bit. Of course, you have to use one of the PCs if you need these special interfaces for the cameras like Co-Express or Camera Link. If you need a Camera Link or Co-Express camera, then there's no questions. Even you cannot think about a smart camera because a smart camera cannot have a Camera Link sensor inside. Of course, Camera Link and Co-Express is built to make it externally for really high speed application. But as I said, in let's say 80% of all machine vision solutions, you don't need this high speed solution. And let's say for another, if you use the GigE solutions with up to 10 GigE or 2.5 or 5, then we are at 95% where you can use the GigE interface. So only for a very fraction, you need Camera Link and Co-Express, or nowadays only Co-Express, because this is the latest interface bus for these high-speed solutions. Then you need, of course, a PC where you can add the plug-in board. Then you don't have to discuss if you use a smart camera. And of course, if you have these high-speed cameras with maybe 500 or 1,000 frames or 10,000 frames, whatever, and you want to do the evaluation on these images, you need also a really high-power solution. That means you need a discrete setup, either with an x86 or an ARM CPU inside, a high-speed ARM CPU inside. So the decision at the end is maybe to make it simple. If you have a smart camera and not so complex applications, or you have a moderate processing. I already mentioned moderate processing. I would say we have customers who use smart cameras, even the small one, with 15 parts per second. So let's say moderate is 15 parts or 10 parts per second. Or the budget constraints. Of course, you have mostly a lower initial investment, mostly, if you don't need these special smart cameras with maybe AI inside, which are then based in the higher cost level. So the calculation has to be done finally with the cabinet and all the other stuff together. I think one of the real advantages is the limited space, because you only connect the smart camera and that's it. No other cabinet or whatever is needed. Of course, the scalability is not given, because you buy the camera with the sensor and with the CPU, and if you realize, okay, the resolution is too low or the speed is too low, you have to replace it and you buy another one. If you have a PC, of course, you can buy simply another camera with a high resolution and it works. And because everything is somewhat more compact with a smart camera, the development is much quicker because of the not so complex task. Of course, this is also an overall discussion, because we do this for a long time, and we have also customers who have really large programs which run in the smart camera. So it's not for the average. It's for the average, but not for all reasons, to say, okay, the development is much quicker. So, and of course, the nice thing is you buy the smart camera, I know exactly I have two connectors, I connect it, I do the configuration, and then it runs simply. And yes, I just went through all of this, and then you see at the end, of course, for complex tasks and especially for complex AI-driven tasks, we recommend always a PC-based system. Especially, you don't have to think about optimizing the AI networks for the edge devices. You simply can use the standard networks and it runs. To have a short overview which hardware we support, but you find it also on our website. you can see here, these are as well the smart cameras from different manufacturers. Right now we see, of course, we have a light which now subsummarized, I think, ChromaSense and Ulysses and so on. So maybe we can reduce some of these logos now, but only to see that you have a really wide range of hardware which you can use with the software. Especially you have this one software and then you can decide which hardware fits best to my needs. And of course, sometimes it's difficult. If you need some help, we are always happy to help you. If you give us a description of your task, we can give you a description which hardware fits perfectly for your solution, or which two options would help, and then you can decide, okay, this hardware fits for this task, this hardware for this task, or vice versa, whatever fits best for your ideas. And of course, I would have made this webinar last week, but we had some technical problems. So we released last week the latest version of our software, which you can download since then, with a lot of new features, especially also for the AI stuff, which we have built in the software, so that you have some new features also in the 3D area. And of course, we have a very new GUI system to make this time to market solution with a nice user interface right away with the software, with simply configure the solution and deliver it. So yes, today our webinar is a little bit shorter, but I hope you get a short, rough idea about the differences, or when to use a smart camera, an embedded system, or a PC system. Of course, you cannot say, okay, that's only the right solution for that. What we know is right now, if you know exactly, I only have to read one code on the production belt, a smart camera is the right thing. If you say, okay, today I have to read the code, maybe tomorrow I have to do also some recognition of the packages which run on this belt, then maybe the smart camera is not the right solution. If you know, of course, the recognition is based on a smaller network, also some of the smart cameras would do it. So that's why I said, if you have any question about which hardware would work best for you, simply write us a mail and we try to give you some ideas what would fit to the solution. Of course, if we do this, we have always the idea to use it with based on our software, of course, but we can give you a real big choice of all the different hardware manufacturers which could fit for these needs. So yeah, that's all for today. I hope it was somewhat interesting for you. And if you have some questions, feel free to ask me. I'm here. If not, I would say thank you that you took the time. And yes, we can stay in contact. Yes, I have a question. You're welcome. And this was also thank you. So thank you very much. And in this case, I would say bye-bye. And I hope I see you in one of our other webinars again.